Hello everyone, I'm Laura and I'm passionate about all things gadgets, electronics, all kinds of smart devices that allows us to explore the world of technology and create all sorts of interesting things. Today I'm super excited to introduce a new addition to my collection of tech devices, which I'm sure will pique the curiosity of many of you. At first glance, some of you might confuse it with Flipper Zero. However, while it shares a similar form factor, it is a completely different device with unique purpose and capabilities. And this is the LilyGo T-Embed ESP32-S3. This is a compact and powerful development module from LilyGo, which integrates several key components, making it ideal for IoT, Internet of Things projects, control systems, radio communications, and experiments. It's not a ready-to-use product in the sense of a Flipper Zero, but rather an open platform for building your own inventions. The heart of this device is a dual-core Tensilica Extensa LX7 microcontroller, optimized for IoT applications. This means it has enough processing power to run complex tasks. It has a powerful processor. Let's quickly see what its default menu shows us. I will navigate and highlight what's important. Settings. Here we adjust basic screen settings, connectivity, and other preferences. Infrared. This option is ready to function if we connect an external IR module. This way you can control remote controls or IR system through programming. Music, a small integrated audio player useful for sound alerts or small musical distractions in projects. Wi-Fi. Here is one of the ESP32-S3 strengths in this device. We can connect the LilyGo T-Embed to our wireless network to access the network or communicate with other devices. Essential for any online IoT project. Battery. Here we can check the level of battery and see also some other informations. Next option is NFC, near field communication. Similar to infrared, the NFC option indicates that we can add an external NFC module. This way we can read and write NFC tags or interact with contactless cards, opening new horizons for creative projects. WS2812 refers to the control of addressable RGB LEDs known as NeoPixels. Through this option, we could program beautiful light sequences and dynamic visual effects for our projects. Here we are at the last option, SubG. This is the heart of CC1101 module. Here we can explore and interact with radio frequencies below 1 GHz. We can listen to wireless signals, transmit data, or even communicate with various devices remotely. It's a super powerful functionality for radio experiments. Think about 433 MHz, 868 MHz, or 915 MHz. Common frequencies for remote controls. Now that we have seen the menu, let's talk about what projects you can build with the LilyGo T-Embed. The possibilities are almost limitless, but here are a few ideas. Smart home monitoring system. You can build a temperature and humidity sensor that sends data to your phone or web server. Remote control system. Create a personalized remote control for a specific light or a garage door using the SubG or infrared functionalities with an external module. RF communication device. You can experiment with transmitting or receiving short-range radio messages exploring various protocols. A mini robot controlled via Wi-Fi or Bluetooth, or a data logger that records environmental values for later analysis. Custom firmwares and extended capabilities. Among the most popular development frameworks and firmwares you can use are SPIDF, Expressive's official development framework ideal for complex projects and maximum performance. Arduino IDE. If you are familiar with C++ programming within the Arduino environment, you can use this IDE to program the T-Embed, having access to a multitude of libraries for sensors, displays, and communications. MicroPython. For those who prefer Python, MicroPython transforms the T-Embed into an easy-to-program device, ideal for rapid prototyping. And with these custom firmwares, the capabilities you can add are immense. Think about connecting to sensors and actuators, reading data from almost any type of sensor, temperature, humidity, motion, light, and controlling relays, motors, or lights. Smart home automation, creating customized systems to control lighting, thermostat, or home security. Advanced monitoring devices, building portable weather stations or complex air quality monitoring systems. Mini web servers, turning the T-Embed into a local web server to control devices via browser. Simple games, even creating retro games on its screen. And one of my favorites, cybersecurity projects, exploring Wi-Fi or Bluetooth vulnerabilities, always for educational and ethical purposes. Beyond basic applications, the LilyGo T-Embed's capability extend into the realm of cybersecurity. Its integrated Wi-Fi and Bluetooth modules combined with a SubG radio make it a powerful tool for understanding various wireless communications protocols and their potential vulnerabilities. Some of the things you can do: packet sniffing and analysis, capturing and examining wireless data packets to understand network traffic, deauthentication attacks for testing purposes only, learning how Wi-Fi networks can be disrupted, Bluetooth low energy device scanning, discovering and analyzing nearby Bluetooth devices, radio frequency signal analysis, investigating common 1 GHz protocol used in various smart devices. It's a fantastic device for learning, exploring, and putting your ideas into practice, especially if you're looking to get more into practical cybersecurity concepts. As you can see, the LilyGo T-Embed ESP32-S3, it's an incredibly versatile device. Although it requires a bit of programming to unlock its true potential, its flexibility and components make it a fantastic tool for anyone wanting to create their own smart solutions. It's perfect for electronics and programming enthusiasts. The possibilities are practically unlimited once you start programming. I hope you enjoyed my video. Until next time, stay curious and creative. See you soon.